Hi everyone, welcome to our online lesson, part 2 of our notes 2.2 surface area. So in class we started looking at surface area. We did the first 2 examples of our notes. So we are skipping ahead in our notes and we are looking at example 3. Okay, so we're in our notes, that is page 3 of your notes. And in example 3, we're asked to calculate the surface area of a cylinder. A cylinder is a lot like a can. A can is simply the shape of a cylinder. And we're given some dimensions. We have a height, h is equal to 5 centimeters, and it says the radius of the circular base is equal to 3 centimeters. It's really helpful for me to draw myself a diagram whenever I have any type of problem related to an object. So I could go to my data pages if I wasn't sure what a cylinder looked like and have a look. There's a picture of a cylinder on page 3 in my data pages. But a cylinder has 2 circular bases, one on the bottom and one on the top. And then it has a height. And so it looks like this. And I am given some information here. It says that this is my base. Here's my circular base. Okay, and it is a circle, and I'm told that the radius is equal to 3 centimeters. So let's put in the information that we're given here. So the radius of my circle is from the center of the circle out to the edge of the circle. So R is equal to 3 centimeters. I'm going to write that down right away. The other piece of information I'm given is the height of my cylinder, which is going to be from the base to the top. Okay, so the height of this cylinder is 5 centimeters. Okay, I'm asked for the surface area, so let's use the formula for surface area for this. Surface area in this case is going to be equal to, we've got 2 circles. So we've got a bottom base, and the top base is also a circle. Plus we've got this whole curved area, and this curved area, the area of the curve, okay, or there of the middle of this can, is called the lateral area. Any curved surface, we call that the lateral area if we're referring to the area of a curved surface. Okay, and so the surface area is going to be the lateral area plus the 2 circles. That's really what I'm looking at here. Okay, and I have this formula, and it looks like this. Surface area of a cylinder is equal to 2 pi r squared plus 2 pi r h. Okay, I took that from my data booklet. And if you actually have a look at your data booklet for just a moment, I'm just going to go to it quickly. Pull up our data booklet. If we're looking at a cylinder, so let's just come over here for a moment. Okay, so if we look at the last page in our data booklet, if we're looking at a cylinder right here, there's the formula for surface area. That's the one that I just wrote down on my notes. Notice that the 2 pi r squared there comes from here. Okay, that's the area of the top, which is a circle, and the area of the bottom circle. Okay, so that's the 2 bases, the area of the 2 bases, plus the area of the side, and this is also called the lateral area. Okay, so this is just the side. So we can go back to our notes for a moment. The reason you can just use the formulas, that's fine. I just want you to understand where they come from. Okay, so this pi r squared, that's the area of a circle. Okay, and the 2 comes from the fact that we have 2 circles here. So this part here, this is our 2 circles. That accounts for the 2 circles, and that accounts for the curved side, or what's called the lateral area. Okay, that's all this is. So we can go ahead and plug in our information. I know R and I know H, so let's do the math. Surface area equals 2, we're going to keep this all together here, 2 times pi, okay, times r squared. R is 3, we're given the radius, and I have to square it, okay, plus 2 times pi times h, which in this case is 5 centimeters. sorry, times r times h. So 3 centimeters times 5 centimeters. Okay, so surface area is equal to, if I put those numbers together, okay, I get 2, this is the same as, by the way, 3 squared is 3 times 3, which is 9. So if I wanted to simplify this a bit, this is 2 pi times 9, okay, plus 2 pi times 3 times 5. So 2 times 3 times 5, this is just 30 pi. Okay, 2 times 3 is 6. 6 times 5 is 30. Okay. Now you could always do this in one step as well. So let's work these numbers out. 2 times pi times 9, or 18 times pi, is equal to 56.54, and I can round it to 9. That's what I get from my calculator. And 30 times pi, or 2 times pi times 3 times 5, is 94.248, if I round it there to the thousandth decimal place. And so if I add those two numbers together, I get a surface area of 150. And I'm going to just, it says, well, it doesn't tell me where to round it, but we'll round it to the first decimal place. Okay, 0.8 centimeters. I'm talking about area. Square centimeters will be my units. Okay, and there's my answer for this one. So the trick is recognizing the type of object you have. Drawing yourself a diagram if you don't have one is really useful. Finding our formula, okay, and then really plugging in the values that were given into our formula. Okay, and the rest is just calculating. Let's do another example. Oops. So example number 4, get rid of that. Calculate the surface area of a sphere with a radius of 7 millimeters. Again, if you don't immediately recognize what a sphere is, by the way, a sphere is a ball. Think of like a tennis ball or a basketball, anything spherical. Okay. Again, you could go to your data pages and look up a sphere on page 3 and draw yourself a little diagram. Okay. So if I look at page 3, I see that a sphere looks like this. It's a 3-dimensional circle. Right? So we have, it would look like this. Okay, and a sphere has a, just like a circle does, it has a radius. Okay, it also has a diameter, which would be equal to 2 times the radius. The diameter would be all the way across the sphere. And in this case, we're told that the radius is equal to, or is equal to 7 millimeters. And if I look at my data booklet and I look for surface area, and I ask myself, what is the formula for surface area of a sphere? One of the things I notice here is that the only thing I need, here's the formula, 4 pi r squared. The only thing I actually need to calculate surface area is the radius, right here. That's the only thing I really need, okay? And then when I put it into my formula, I have to square it. So let's do the math. Surface area is equal to 4, okay, times pi, times 7. This is 7 millimeters, but I'm going to drop my units just for the moment to keep it simple. 7 squared. Okay, I do have to square that. That's the same as 4, okay, times pi, times 7 again. Now, again, in your calculator, you can use the square button in your calculator. Okay, so you could also say that's 4. Let me put this over here in your calculator. If you're using your calculator, 7 squared in your calculator, okay, is going to be 7. And we hit that little button that looks like this. Okay, our square button. 7 squared, that gives us 49. Okay, times the rest of it, times 4 times pi. Okay, in your calculator. And your answer is going to come out to 615.8 if I round to the first decimal place. And my units are, I come back here and I look, I was in millimeters for my radius. And because those millimeters, that 7 millimeters was squared, I now have millimeters squared. And that's my surface area. And I expect to have square units because I'm talking about area. And there's my answer. Okay. Your worksheet 2.2 asks you to do some very similar questions where you're calculating the surface area of various objects, cylinders, pyramids, spheres, rectangular prisms. Okay, and you're going to be using your data booklet for this. So you're going to be getting very used to these formulas. On page 3 of your data booklet, remember that on the first column here, surface area, there's your surface areas. Okay, for spheres you have two, one where they use the radius and one where they've simply used the diameter if you're given the diameter instead. Okay, for a cone, we did one of these examples in class. There's your surface area. Square base pyramid, again you have a surface area for that. And oops, if we come down a little bit, let me just move this over. Okay, a rectangular prism is just like a box. The surface area is equal to all of the sides added together. But again, if you make yourself a diagram and label it, okay, it's simplified here for you. It's 2 times the width times the height plus the length times the width plus the length times the height. And we talked a little bit about a right pyramid. Okay, and a right pyramid, the right prisms, generally you're only going to see this type of a prism, which is a rectangular prism. And so for our course, this is sufficient. But for the right pyramid, remember you have the extra sheet that I've given you. Okay, and it shows you a net. So we have an extra sheet and it gives you a net. And that's for a rectangular pyramid. Okay, a little bit different than a square-based pyramid up here. Okay, so try some of those questions out and check your answers. The worksheet key is posted on the website. Thanks for joining me.